So before we continue with the binomial distribution, I do want to show you guys one thing that I've uploaded on Canvas. So if you click on modules, and then you will go down to the calculator stuff and resources. So there's a third thing that I just uploaded, which was called probability notation for discrete random variables. So let me go ahead and click on that and let me download it. So you'll see something that kind of looks like this. And basically what this is just keywords to kind of help you figure out what the probability would be. So for example, what does exactly 3 mean? Well, that's just probability of x equaling 3. What does less than 3 mean? That's probability of x being less than 3 without being included, 3 or less. So I gave all these phrases and keywords to kind of be able to give you an idea of what exactly the probability should look like. So we will do a couple of that in a little bit. So this is just for you to have. So hopefully this does help. Because I know that sometimes it's really difficult to figure, for example, at least 3, that's usually the most commonly missed one. So that should be probability of x being greater than or equal to 3. So instead of being less than 3. So the only thing that I would advise is to make sure that you are familiar with the inequalities. And if you don't feel still very strong about it, you can just let me know and I can help you out. So this is just for you to keep. So let's jump into more examples of binomial distribution. So this is the last thing that we'll talk about binomial. So if you know that a problem follows the binomial distribution, then here we are given a mean. So the mean of this particular random variable, mu is going to be equal to n times p, where here n is going to be the number of trials or the number of times that we do this or the number of people that we get, and p is the probability of success. So what is the chance that this occurs? And also the standard deviation, SD of x, which is sigma, is equal to square root of mp, 1 minus p. So this is basically, if you want to find the mean or the standard deviation, and you know that this particular experiment or problem has the binomial distribution, you can just use these formulas. So this is only for binomial. So let's go ahead and do some problems. So let me go a little bit down. So here we have an archer hits his target about 25% of the time. Suppose that he shoots 10 times. So one of the things before to even start the problem, notice that what I like to do to know whether this is going to be binomial or not, I want to be able to look for this n and this p. So I want to figure out, is there a number of trials, a number of times that this person is doing it, and is there some sort of probability? So that's kind of what you want to be able to look for. So because the problem will not tell you it's binomial. So notice that here we have a percentage. So this percentage can probably be our probability, okay? Because the probability of him successfully hitting his target is 25%. And then notice that he's doing it 10 times. So this is going to be our value of n. So already we kind of already know what our n and our p is. So our n is going to be 10 and our p, let's convert this to a decimal, is going to be 0.25. So make sure that you always convert it to a decimal. Do not leave it as a percent, okay? So here, part A, we want to know how many times can we expect the archer to land. So how many hits can we expect the archer to land this his arrow? So notice that we're looking for the word expect. Here we're looking for how many can we expect to land. So if we go back up, we see that because we know this is binomial, we know that the expected value, or the mean, that's just another fancy word for mean, is going to be n times p. Okay, so that's the formula that we're going to be using. So we're going to use the expected value. So you can either write it like this, e with the brackets of x, or you can just write mu is equal to n times p. And in this case, it's going to be equal to 10. P is going to be equal to 0.25. Okay, so if we go to our calculator, 10 times 0.25, that's going to give me 2.5. So he can basically expect to land about 2.5 arrows, okay, for his target. Okay, so let's go to the next problem. And then the next problem, it says find the standard deviation. Well, we know the formula for the standard deviation. If we go back up, this is binomial, so this is going to be the standard deviation for this guy. Okay, square root of np, 1 minus p. Okay, so sigma, my standard deviation, or you can write SD of x, doesn't really matter. It's going to be equal to the square root of NP 1 minus P. Okay, so n in this case is going to be equal to 10. P is equal to 0.25. Then I'm going to do 1 minus 0.25. Okay, so let's put that in our calculator. So we have the square root of 10 times 0.25, 1 minus 0.25. Okay, and what that's going to give me about 1.37 if I round it to 2 decimal places. So let me put approximately here. So this is approximate. Okay, so this is a standard deviation. Okay, so now let's do the last two problems. So for this one, part C, what is the probability that fewer than 4 will land? Okay, so notice here that now we have some keywords. So we're looking for fewer than 4. Okay, so if I go back to my little cheat sheet right here and we look at fewer, notice that it's right here. Fewer than 3 is basically probability of x being less than 3. So there's no equal to. So basically what this is saying is that we're not including this 3. I'm doing fewer than the number, so we're not going to include that. So let's go ahead and put that down. So it's going to be probability of x being less than, in this case we don't want 3, we want 4. Okay, so I'm just reading it based on the little cheat sheet that we have. And then we know that because it's less than, this is going to be a binomial CDF problem. And if you still need to refresh your memory on how to use binomial CDF, just watch the previous video from this. So this is going to be n equals 10. P is going to be equal to 0.25. And x in this case, notice that we're not including the 4 because there's no equal sign there. So we're going to go one number less, that's going to be 3. Okay, so we're going to go into our calculator, second data, distributions, go down to binomial CDF, and then we're going to have, the first one is going to be 10, P is going to be equal to 0.25, and X is going to be equal to 3. Okay, so we're going to go ahead and put equals, and we're going to get 0.7759. So if I wanted to round to 4 decimal places, it would be that. Okay, alrighty. Okay, now let's do the last problem. So the last problem says, what is the probability that at least 6 will land? So here what we want to do, we want to figure out what does at least 6 mean. So if we go back to our little cheat sheet, at least 3 is basically probability of x being greater than or equal to 3. Okay, so in this case, we're going to have the probability of x being greater than or equal to, not 3, but 6 in this case. Okay, and one way that I kind of remember this is that if you want to say whenever you see the word at least, if you say I need to be at least 21 to get into the club, I have to be 21 and over. So at least 6 will be 6 or more. So it's more than or equal to 6. Okay. So remember that with binomial CDF, this is going to be another binomial CDF, but you cannot do greater than, so you have to do 1 minus the probability of x being less than 6. So you switch the sign and you get rid of the equal sign. All right, so this is going to be equal to 1 minus, this is just going to be a binomial CDF problem. Binomial CDF, n is equal to 10, p is equal to 0.25, and x in this case is going to be equal to not 6 because it's not equal to it. It's going to be less than 6, so we're going to go down 1 by 5. So we're going to put this guy into the calculator. Second data, distributions, binomial CDF, and then we're going to do 10.25, and then x is equal to 5 now. So what I'm going to get is 0.9803, around there, rounded 4 decimal places, and then I'm going to just subtract this. So I'm going to do 1 minus 0.9803. This is equal to 0.0197. Okay, so that is a probability of that occurring. So yeah, so just be very careful. You have this cheat sheet with you so that in case you ever forget what any of these phrases mean, you'll be able to kind of figure them out. I kind of just told you what the probability of this would be. And then just don't forget to be able to do binomial PDF, binomial CDF, and also know that if a problem is binomial, then you have formulas for the expected value, the mean, and the standard deviation, SD of x.